Hi there, this is the last section that we're going to cover in Chapter 1, and it's titled 1.5, Solving Inequalities and Interval Notation. I don't think your book, when you get your books, mentions the interval notation, so that's the additional piece that we're going to do together. You've all heard of inequalities, so the first thing that I want to make sure that we are all on the same page with is what an inequality actually is. So think about what your definition of an inequality would be for a second, and then we'll just write down some basic notes as far as what you should remember about them from previous courses. So an inequality basically is very similar to an equation, but the big difference is that we have inequality symbols involved in our writing. We're going to use our greater than or less than or greater than or equal to or less than or equal to instead of actual equal signs. So you're going to see these pop up. Things like 5 is greater than 2 is considered to be an inequality, or x minus 3 is less than or equal to 16. That's considered to be an inequality. In this section, we're going to be looking at situations that look a little bit more like this, as opposed to something like just basic, like 5 is greater than 2. So one thing that you do have to remember, though, is if you think back to 8th grade when you actually did work with these in Algebra 1, if you use the operation of division, so if you're dividing or you're multiplying by a negative value within your solution process, the direction of the inequality has to change. So you need to change that direction of the way the inequality symbol was pointing if you multiply or divide through by a negative value. So we have to remember that as we go through some of these examples. Whoops, this went backwards. I'm going to switch screens here, and we're going to actually look at a few examples together. This one says solve and graph the solution set on a number line. So the direction solve means we want to end up with a value for the variable. We'll talk about the graphing in a second after we do the solution. I think you've done the graphing before too, and it may be just bringing back things into your memory. So when we go to solve this inequality, this is our inequality piece right here. We treat it as if it were an equal sign and go through the solution process exactly the same. Just keeping in mind if we multiply through or divide through by a negative, we got to change the direction of it. So if I'm trying to isolate the c, I have c on both sides. The first move should be multiplying both sides by 6. And that's going to get the 6 out of the denominator on the right-hand side. So we have negative 24, c, is less than or equal to, over on this right-hand side, the 6's drop out. So we're just left with 5c plus 58. We want to isolate the variable, so I'm going to move the 5c over to the other side through subtraction. Now I'm showing all my steps here. At the beginning, you guys probably should too, so that you get used to the process again. But after a while, some of the steps that are basic you can skip over. We get negative 29c is less than or equal to 58. Divide both sides by negative 29. So this is a point where we need to be aware of the fact that we divided by a negative. This leaves us with c is greater than or equal to negative 2. So that tells us that any value from negative 2, including negative 2 because of this equal bar here, can satisfy our original inequality. Graphically, and I think you've done this in the past too, is if I ask you to graph the solution set, then that means that we're going to actually graph the scenario that we were presented with here in our answer. If we go to negative 2 on the number line, we want all values that are greater than or equal to negative 2. Think back to Algebra 1. The way that you graphed this was you put a closed dot, closed because you were working with the equal sign. And we'll take notes on that in a second on the next screen. But any value that's equal to negative 2 or greater than, which moves to the right, is going to be a solution to that inequality. So I'm just going to draw this line up above. that heads towards the right with an arrow on the end to indicate that it keeps going. This is considered to be the graph that I would want to see. This is our solution, and that's our graph. So I am going to introduce you to a couple things on the next slide, or revisit one of them and introduce you to another one. Keeps going backwards here. Here's our basic graphing rule. When graphing the solution set, keep in mind that we need to look at the inequality symbol in order to figure out exactly how to graph. If we have, let me switch colors. If we have less than or equal to in our solution set, we use an open dot. So that looks like that on the number line. And if we have greater than or equal to or less than or equal to, we're going to use a closed dot like we did in that example previous and actually bubble it in and then make our arrow go in either direction. Now, we just write our answer as C is greater than or equal to -2. That's pretty basic notation. This year, we're going to move towards something a little bit more advanced called interval notation. So all of our inequality solution sets, like the one that we just got, are going to be written with interval notation. If we have in our answer a greater than or a less than, I'm going to show you that, tell you right now that we're going to use parentheses around our answers. So you guys all know what parentheses are. I'll illustrate what's going to happen in the answer in the next problem. Greater than or equal to or less than or equal to is going to be a bracket situation. And then you need to keep in mind that if we have positive or negative infinities, we are going to always use parentheses on those. And the reason why we don't bracket it off is that infinity doesn't have, or negative infinity doesn't have an actual end. We can't put a value to it. So that's why the parentheses are used as opposed to the brackets. So this solution set that we just had in the previous example, C is greater than or equal to -2. This was our graph. We bubbled in and we went to the right. So this is telling us the absolute lowest value that we can use is -2, including -2. When I jump from this notation to interval notation, I take the lowest value possible first and write it as -2 and figure out if I'm going to bracket that in or parenthesis that in. Because of the equal bar in this situation, we're going to put a bracket to the left of it. Now, all of our answers can keep going. According to our graph, we can keep going all the way up until we reach positive infinity. So it's going to look like a point, but I'm going to write comma, positive infinity, and parenthesis around it. So this tells us exactly what we got in our original solution set. All values from -2, including -2 because of the bracket, all the way up to infinity with a parenthesis because we don't have an end value to infinity, are included in our solution set. This is our interval notation. So I would like you to use this notation in all of your solutions for solving inequalities. If you have any questions on it, write those down. It takes a little while to get used to it. In fact, every year when I revisit this with my juniors at the beginning of the year, they forget what it is. So we will use it often enough where you should be able to remember it. The next example says to write your answer using interval notation and graph your solution. So basically solve and provide me with a graph again. In this instance, we have distributive property on both sides of the inequality symbol. I'm going to distribute the -6 through and get 24v minus 18 is less than or equal to 20v plus 6. Make sure you're distributing to both terms. To solve, I'm going to isolate the v over on the left and get 4v. I might as well move the -18 over to the other side at the same time as well. Is less than or equal to positive 24. And that means that v is going to be less than or equal to 6. No change in the direction of the inequality symbol there because we didn't divide through or multiply through by a negative value. So if we want everything smaller than or equal to -6, that means the lowest value that we could possibly have would be -infinity. And the highest value that we could possibly have would be +6, including 6. So this right here is our answer written in interval notation. The graph would look like this. Here's 0, here's +6. I'm going to put a closed dot at +6, and I'm going to move to the left this time. So if you notice, I'm not really critical about where you are exactly, like 6 units away from 0. Just know that it's got to be to the right and that you've got to place it somewhere to the right in order to start your graph off. And then the arrow is going to go to the left because we're going towards more negative values. Let me know if you have any questions on that when I see you next in class. And we're going to do one more, and then that will be the end here. Again, directions say solve, same as before. Write your answer using interval notation and graph your solution. So this one looks a little bit like the first one that we did together. I'm going to multiply both sides by -4. 8y is greater than -5y plus 9 over -4. I'm going to get rid of the fraction in the denominator, multiply by -4, multiply by -4. So that leaves us with -32y is greater than -5y plus 9. I'll add -5y over to the left and get -27y is greater than 9. Divide both sides by -27, and y will be less than, because I'm dividing by -1/3. Interval notation is going to tell us that 1/3 is the greatest value and -infinity is the smallest value. So -infinity up through 1/3 is what makes sense for the solution set, with a parenthesis on both sides because the 1/3 is not included. And then the graph, here's my 0, 1/3 can be to the right of it because it's positive. I want everything smaller than 1/3. Open dot because it's not included, and then arrow to the left. So we've got a couple different pieces where our solution is indicated. Here using interval notation, and here graphically. Those are the two pieces I would look at in order to grade a final answer. Y is less than 1/3 written like this is your process to go through the work, not your final answer. So if you left your answer that way, I would take a little bit of credit off because I want you to be geared towards this interval notation. That's the end of the section. Let me know again if you have any questions. We'll go through whatever questions you have in class and then try to tackle some practice problems. So that's going to be it right now for chapter 1. We have one more section within the entire chapter to go through before we were to assess probably on it, but we'll do a couple little formatives prior to that. But first things first, when you come into class, we need to at least do some practice before we even start thinking about assessments. So thanks for listening and taking good notes, and I will see you in class.